pressure of the left ventricle as 120 over 8. So we would see this pressure tracing would go up to about 120 millimeters of mercury, and then it would drop down to about 8. Now, if I were to continue to take that catheter and pass it through the what? The valve here. What valve is that?
Pulmonary.
Well, we haven't gotten to heart yet, so that's going to be the aortic valve. So once I get through the aortic valve here, and now I have my pressure tracing in this vessel, you should know. Huh? It's the aortic arch, right? Or part of the ascending aorta there. Okay, so now I have my catheter there. What kind of a pressure tracing am I going to see? We determined that this is the pressure tracing when I'm in the left ventricle, oscillating between 120 millimeters of mercury and about 8. But now, when I am in the aorta, my pressure tracing is going to look like this waveform right here. And you can see it oscillates to about 120, and then it comes down a little bit, but never goes back down to the pressure that I had in the left ventricle. It stays up and goes back up, down, up, slopes down, and up again. Okay. So what are we going to call that type of a tracing? That's going to be aortic pulse pressure tracing. And then if I were to continue to take a catheter, pressure catheter, and pull it further and further out to the point, to the smaller caliber vessels, all the way out to the area of the arterioles here, where would that pressure tracing be? It would be over here somewhere. Okay? Sort of dampening the oscillations, but still relatively good pressure. In fact, it almost overrides the pressure tracing in this solid line. What does this solid line represent?
This is
Huh?
the mean pressure.
The mean. Yeah, it's the mean. Now, a couple of things about that in just a minute, but let's continue to follow this tracing. So now I've got this pressure transducer that's recording these pressures here, and let's say I can't get into the capillary beds there, but I'm going to go into the right side of the circulation. I'm going to work my way through the right atrium into the vena cava, and I'm going to work my way into the venous system. And look what I end up having in terms of a pressure. Fairly low pressure, right? And then eventually if I pull the pressure transducer here into the right atria, what kind of a pressure am I going to see? A little leap of pressure there, right? But still relatively low pressure relative to the arterial side. Okay, notice that you guys said this is a mean arterial pressure here. But isn't the mean sort of like halfway through there? Should the mean be like here?
Is it because it's in all the arteries, not just? Wait.
No, it's not for that reason. The reason being is that when you take the mean arterial pressure, which is this formula here, let's take a look at it, how that's determined. Mean arterial pressure is going to equal the systolic blood pressure, which is represented by the peaks of these things, plus twice the diastolic blood pressure, which is sort of the troughs here, divided by 3. And why would that be? Why don't I just take the systolic blood pressure plus the diastolic blood pressure and divide it by 2?
Spends more time in this diastolic.
Absolutely right. So the heart actually, in the cardiac cycle, spends twice as long in the diastolic phase than it does in the systolic phase. So in order to get the mean arterial pressure, you've got to take that into consideration. There's another way that you can determine mean arterial pressure, and that's from the pulse pressure. What do I mean by pulse pressure? What is pulse pressure? It is the difference between the systolic and diastolic pressure. That is the pulse pressure. The difference between systolic and diastolic pressure. And so you can use this formula where you subtract the systolic blood pressure from the diastolic blood pressure. times 0.33 plus the diastolic blood pressure. And these both will give you, if you plug in your average, why don't you do that as an exercise? Just plug in systolic blood pressure of 120 and and a diastolic blood pressure of 80. And work through the formula and see what you get.